In lesson 2.2.4, we worked with the equation x squared plus y squared equals 25. And what we did is we found some different values for x and for y that will work with this. We had examples such as 3 squared plus 4 squared equals 25, and we could plot the point 3, 4. We also had negative 3 squared plus 4 squared equals 25. So we could plot the point negative 3, 4. We also had points such as 3 squared plus negative 4 squared equals 25, and 3 or negative 3 squared plus a negative 4 squared equals 25. And through a series of points here that we plotted on a graph, we found out that this was the equation of a circle with a radius of 5. We then went on and said, what if we solved this equation here for y? So the first thing I needed to do is subtract x squared from both sides, and I would have y squared equals 25 minus x squared. Taking the square root then of both sides, I end up getting y equals both the positive and the negative square root of 25 minus x squared. The reason why we need both the positive and the negative here, because when we graph this, it's no longer a function. So a quick sketch of this would look like the positive part would go from here to here, and the negative part would go from there to there, making the entire circle. So that's why we need to have both the positive and the negative values. From there, we looked at what do we do with our parent graphs. This is now a new sort of parent graph. And what do we do in order to adjust our parent graph horizontally? Well, what we've always done with all of our other parent graphs was take a look at our x value and replace it with x minus h. Then we also talked about what do we do to move our parent graph vertically up and down. And that was always adding a k value onto the end. This gave us a slightly new equation. The equation was y equals plus or minus square root of 25 minus, and then parentheses, x minus h squared plus k, with the point hk being our locator point, and in this case, the center of our circle. Then the last part of this problem was trying to solve this and isolating 25, getting this alone by itself. So what we needed to do then was think about how do we solve this. So if I look at this equation again, if I want to get 25 by itself, the first thing I'm going to need to do is subtract k from both sides. That gives me y minus k equals both positive and negative values of the square root of 25 minus quantity x minus h squared. Then to get 25 here by itself, I need to get rid of the radical that is over it. So I need to square both sides. So when I square this whole thing here and square this whole side here, I end up getting y minus k squared, which equals 25 minus quantity x minus h squared. The square and the radical cancel each other out. Not only that, but whether I have a positive or a negative value, when I square it, it doesn't matter. It's going to come out positive anyways. The last thing we need to do now in order to isolate the 25 and get it by itself is to remove this part. So I add that to both sides. That gave me the equation x plus h squared plus y minus k squared equals 25. Now this is the equation of a circle that has been horizontally shifted and vertically shifted. I have in here made a slight mistake. That one should be x minus h, because there's the minus right there. So it has been horizontally shifted and vertically shifted, so the center is hk and has a radius of 5, which is the square root of that number there. That gives us the general equation of any circle to be x minus h squared plus y minus k squared equals the radius squared.